This is the exam review for semester 1. The subject is chemistry for grade 7. Our first subject was about matter. Now we said matter exists in 3 states. These are solid, liquid and gas. We first looked into solids and we said that solids have a definite shape and can be held by fingers. And there's a lot of different types of solids, and these are grouped into particular solids or particular solids, and these are like butter and clay, which are known as malleable solids, and these can be easily deformed. So malleable solids, you can easily change their shape, while other solids like flour and sugar are called powdered solids. Another form of matter is liquid. So liquids flow and take the shape of the container. Liquids have an indefinite shape, so their shape always changes. And the free surface of a liquid at rest is horizontal and plane. What do I mean by that? Is whenever I want to draw the free surface, okay, I draw it as a straight line. I always draw it as a straight line. Okay, so this is the example for the box. Put my ruler onto the straight line and then just put it up. It doesn't matter where you put the line, it just has to be straight. So here, just like this. So using these options that we have above, we can categorize them into this table. So we can either put them in solids or liquids or powdered solids. Sand is a powdered solid. So it's a solid and it looks like it's a bit powdery, so we put it into powder solids. So we can write sand here. Oil is a liquid. A comb, so a comb is something that we use for our hair. So that is a solid. Rice is a powdered solid. Scissors is a solid. A stone is a solid. A sugar is a kind of a powdered solid. Vinegar is a liquid. While a flour is a powdered solid. So you can see an example for each category. We then looked at mass. We said the mass of an object represents the quantity of matter that object is made of. So for example, if something has a lot of matter, it will have a bigger mass. While if something doesn't have a lot of matter, it will have a smaller mass. So we then looked at how we can measure mass, and we said a balance is used to measure mass, and we looked at 2 in particular. We saw a digital balance, so this allows a measuring of a mass with an object with great precision, so it's very accurate and it's done by a simple reading. And then we looked at a 2-arm balance, as you can see in the figure below. This is called a 2-arm balance. And then we said that the SI unit of mass is kilogram. And then we looked at how to determine the mass of a solid. So what we do is we place an object on one of the 2 plates of the 2-arm balance. So pretend here I've got object X, okay, and I put that in this arm of the balance. So then that will kind of move the scales a bit. So then I'll have to balance it out. So then I'll put labeled masses on the other arm until equilibrium is reached. So until the two balances are at the same level. So for example, I might here put 2 kilograms, and then I might put another 2 kilograms. So when the two arm balances are at equilibrium, so this side will equal this side. This is what this will let us know what is the mass of object X. So the mass of object X in this case will be 2 plus 2, which equals 4 kilograms. And then we learn how to determine the mass of a liquid. So we have to place an empty container on one of the plates of a two-arm balance. Okay, so here I put an empty container or an empty beaker. We then have to equilibrate it by adding labeled masses. So pretend I put here a mass labeled 2 grams and a mass labeled 1 gram. Okay, and now they are at equilibrium, so now they are at the same level. So I know that the mass of this beaker will be, and we normally call this M1, will be 2 plus 1, which equals 3 grams. Now I want to add the water in, and I want to know the mass of this water. So I take this beaker, okay, and I fill at any, I could fill it at any point. So it will have the 2 plus 1 already on there, so that's the mass of the beaker by itself. But then obviously the mass will increase because I've added now water into that beaker, so maybe I'll have to add another 2 kilograms or 2 grams for it to be at equilibrium again. So we know that now the beaker plus the water will have, we call this M2 with the beaker and the water, will have a mass of 2 plus 1 plus 2. So that will equal 5 grams. We now want to find the mass of that water. So we've found the mass of the beaker, we found the mass of the beaker and water. Now we want to find out the mass of just the water. So we use this equation, M equals M2 minus M1. Remember, M2 is the beaker and water, so it's this one here. We said M2 is 5 grams. We know M1 is just the beaker is 3 grams. So the mass of the water that we've put in is 2 grams. Okay, and this is how we find out the mass of the water or liquid. We then looked at weight, and we said the weight of a body is the force that exerts on the body. The weight is measured using a dynamometer. The SI unit of weight is newtons, and weight changes depending on gravitational pull and location. For example, if I measure my weight in Lebanon, okay, when I go to the equator or something that has a less gravitational pull, or to the moon, okay, my weight is going to be less because weight takes into consideration the gravitational pull. So the mass of an object is constant, while the weight of an object varies depending on the location of that object. We then looked at the conversion of weight, or how to convert between the units of weight. So from ton to kilogram we times by 1,000, from kilogram to gram we times by 1,000, and from gram to milligram we times by 1,000. From milligram to gram we divide by 1,000, from gram to kilogram we divide by 1,000, and from kilogram to ton we divide by 1,000. Let's do some examples with you. So we've got 0.005 ton, and we have to convert it into kilograms. So from ton to kilograms, we have to times by 1,000. So we've got 0.005. Okay, and we have to times by 1,000. So we have to move it this way 3 times. 1, 2, 3. So the answer will be 5 kilograms. We've got 2050 milligrams, and we have to go to grams, so we have to divide by 1,000. So that will be 1, 2, 3. So the answer will be 2.05. You can write the 0 at the end, it doesn't matter, but in convention we don't write it. We've got 1,540 grams, and I now want to convert it to ton. So I have to divide it from grams to go from grams to kilograms. I have to divide by 1,000. Let's do that first. So 1, 2, 3. But now I've just converted to kilograms, and what I want is tons. So then from kilograms to tons, I have to also divide by 1,000. So we have to move it another 3 times. 1, 2, 3. So the answer will be 0.00154. 0.00154. Then I've got 17 kilograms. So 17 kilograms into milligrams. So there's 17. Now from kilograms to grams, I have to times by 1,000. So that I'll have to add 3 zeros. But now we've only got to grams. What I want is milligrams. We'll have to times by another 1,000. So we'll get this big number here, 17 with 6 zeros. 1, 2, 3, 4, 5, 6. We then looked at volume, and we said that the volume of water is the space it occupies in the container. So for example, if it occupies 20 ml, it's 20 ml. If it occupies 30 ml, it's 30 ml. If it occupies 100 ml, it's 100 ml. The volume of a liquid does not depend on the shape of its container. The capacity of the container is the volume of liquid it can contain when full. So if we have a 1 litre bottle and we put 1 litre of water, that's its capacity. You can't put any more. We then learnt how to convert between different units of volume. So we said from meter cubed to decimeter cubed, also known as litres, you times by 1,000. From centimeter cubed, which is the same as saying milliliters. So from decimeter cubed to centimeter cubed, you also times by 1,000. And then from centimeter cubed to millimeter cubed, you times by 1,000. Now from millimeter cubed to centimeter cubed, you divide by 1,000. And then from centimeter cubed to decimeter cubed, you divide by 1,000. And from decimeter cubed to meter cubed, you divide by 1,000. So we've got 0.015 centimeter cubed, and we want to convert it to millimeter cubed. So here from centimeter cubed to millimeter cubed, you times by 1,000. So you've got 0.015, and we have to times by 1,000. So we move this 3 times. 1, 2, 3. So that will equal 15. We've got 7,000 decimeter cubed, and we want to change it into meter cubed. So what we have to do here is write 7,000, okay, and we have to divide by 1,000. So here we have to move 3 times. 1, 2, 3. So the answer will be 7. We've got 0.6 litres here, and we have to convert it to millilitres. From litres to millimetres or centimetre cube, they're exactly the same. You have to times by 1,000. So you've got 0.6 litres, and you want to convert it to millilitres, so you have to times it by 1,000. 1, 2, 3. So the answer will be 600. And you've got 432 decimeter cubed. Okay, you have to convert it to litres. Now decimeter to cube to litres, they are exactly the same, so we can just put the same number, 432. So how to measure the volume of a solid or any shape. So we've got a solid and we want to measure its volume. What we do is we get a graduated cylinder. We put here, we've got graduated cylinder. And what we do is we put water in it. It could be 20 ml, 30 ml, anything. And we call that, for example, let's say here it's 30 ml. Okay, we put 30 ml of water. This is what we call V1. So with V1 we have 30 ml of water. What we do is we add solid into this water. When we add solid, the water is going to go up. Then we take the other measurement. So when the water goes up again, okay, you take the reading, and let's say it came up to 45 mil. So what we do, so this is called V2. Now the water with the solid is called V2. So that's 45 mil. Now to calculate the volume of the solid, we use this equation. V equals V2 minus V1. We know that the V2 is 45. The volume of just the water is 30. So we do 45 minus 30, which is 15 mil. So now we know that the volume of this solid is 15 mil. We then looked at how to know the volume of a particular geometric shape. So if we've got a rectangular prism or a cube, and we'll later on learn how to do cylinder and sphere, we don't have to put it in water. What we can do is use equations, okay, to find out its volume. So a rectangular has a rectangular prism of length A. So this is the length, this is A. Okay, of a width B, so this is the width here, this one here, and a height C, this is the height here, C, okay, has a volume of V where V equals A, B, and C. A times B times C. So if we have something like here, we've got 8 centimeters, and here we've got something like 2 centimeters. This one B is 2 centimeters, and here we've got 3 centimeters. What we do equals V equals A times B times C. We'll always write the equation. So A is 8 times B is 2 times C, which is 3. So we do 8 times 2 times 3, which equals 48 centimeter cubed. Because centimeter times centimeter times centimeter is centimeter cubed. So 48 centimeter cubed is exactly the same as 48 millimeters. And then to do a cube, so a cube of side A has a volume of V where A times A times A, so A times A times A. So if we have, for example, or A cubed, if we have, for example, this, which is 5 centimeters, we do 5 times 5 times 5, which equals 125. Let me just make this clearer for you. Centimeters. So this is 125 centimeter cubed. Good luck. I wish you the best in your exams and I hope you do well.